Hey everyone, and welcome to my channel. Today we're going to be taking a deep dive into the world of calculus. Specifically, we're going to be learning about the derivative of the secant x and secant inverse x function. Now I know what you're thinking, calculus can be pretty intimidating, but trust me, with a little bit of explanation and some cool visuals, we can break it down into something that's actually pretty easy to understand. So let's imagine we have a circle with a radius of 1 unit. Now, draw a line from the center of the circle to a point on the circle. This line forms an angle of x radians with the horizontal axis. We can also see that the length of the vertical part of the line is sine x and the length of the horizontal part is cosine x. Now let's increase the angle by a tiny amount dx. What happens to the vertical and horizontal parts of the line? Well, the vertical part will increase by cos x times dx, and the horizontal part will decrease by sine x times dx. This is because as the angle gets bigger, the vertical part gets longer and the horizontal part gets shorter. To know why that is the case, you can refer to the video links given in the description or click on the I button to watch those videos. Let us start with the proof of the derivative of secant x. The definition of secant x is 1 by cos x. To find the derivative, we would need the change in the function secant x, which is equal to secant x plus dx minus secant x. This can also be written as 1 by cos x plus dx minus 1 by cos x. Finally, we can write cos x plus dx as cos x minus sine x multiplied by dx. Now, our aim is to find out the difference between the two terms. This will give us the change in the secant function. For that, we would need to simplify the first term to secant x plus or minus the change. That way the secant x gets cancelled, and we would be left with only the change in the secant x function. With that in mind, we can visualize secant x as the number of cos x values that can be inserted inside the hypotenuse of unit magnitude. In the first term, we can notice that cos x is reduced by a small value of sine x multiplied by dx. We will first insert this reduced cos x value into the unit magnitude so that we get the reference secant x. Then we can notice that there is some length that is not covered represented in blue color, and the length is formed due to the sum of all the sine x multiplied by dx length subtracted from each of the cos x lengths. So the total sum of the uncovered length will be 1 by cos x multiplied by sine x dx. This length needs to be divided by the denominator to get the deviation from the secant x value. But the denominator has an infinitesimal value sine x dx, and the numerator also has this term. Such cases will give terms with values in the second order, dx squared, which are very small and hence ignorable. And also the simplification process becomes complicated. Hence, a small change in the denominator can be ignored, and we can divide the numerator by just cos x. This will give the change in value of the function secant x as secant x multiplied by tan x dx. And finally, when we take the ratio of the change in the function to the change in the independent variable, we would get the value of the derivative as secant x multiplied by tan x. Now, let us look at the derivative of secant inverse x function. Secant inverse x takes the value of secant and returns the angle theta. We will follow a three-step process of getting the derivative of secant inverse function from the derivative of secant function. In the first step, since the independent variable x represents the secant value rather than the angle, we would need to denote all the angle notation in terms of theta rather than x. In the second step, we will denote all the terms in the secant derivative in terms of x. Theta can be written as secant inverse x, secant theta as x, tan theta as square root of x squared minus 1. Finally, in the third step, we will take the reciprocal of the equation to get the derivative of the secant inverse function. There you have it. A geometrically intuitive way of deriving the derivative of secant x and derivative of secant inverse x. If you liked the video, then press that like button, share it with your friends, and subscribe for more amazing content.